Okay, so today we are solving the problem valid mountain array. It says that given an array of integers, return true if it is a valid mountain array, where it is valid if the length of array is more than 3, greater than or equal to 3. Okay, and there exists some I such that all the elements until that I are lesser, and all the elements after that I are smaller. Okay, sounds good. So it has to be strictly increasing and then strictly decreasing. If at any point it is not, then it's not a mod. Okay, sounds good. So the basic idea here is to start from the first element, keep on going till it's increasing, and then once you find the element that is not increasing from that point on, all the elements after it should be decreasing. So if that case is satisfied, that means the mountain is valid. So okay, let's start with an I, which will start from 1. Let's start with 1 because what I'm going to do is I'll do it till while my I n is array dot length, and while my I is less than n, and my array of I, since it should be strictly increasing first, array of I should be greater than array of I minus 1. If that's the case, I'm keep doing I plus plus, and after this what I'll do is while my I is less than n and my array of I, it should be decreasing, so array of I should be less than array of I minus 1, right? Now one thing to note here is that when we are running this loop, right, we could have a case where all the elements are like 4, 3, 2, 1. So now in this case, here my I will still be 1 because all the elements before this, they were not lesser. So in such case, there was not a mountain before, like it is just strictly decreasing, there's no strictly increasing. So I need to check if my I was still 1 or my I reached the end of it. This means that my peak of the value cannot be at the start or at the end of this. So if that's the case, I'll return false. And then if that's not the case, so let's say it was something like 1, 2, 3, 4, I reach here and then I will be here. This does not satisfy. I'm going to check area of I is less than this. I'm going to do I plus plus till this. And then here I'm going to check that my I is the last element. If my I is equal to n, that means this was a mountain. Else I'm going to return false. So it can't be something like this basically, because here what will happen is my I will reach here, right? And then this is not satisfied. So this is still not a valid mountain. So yeah, this looks good. Let's run this. False, false, true, false. Looks good. Submit. Yeah, awesome. In terms of space and time complexity, the time complexity of this would be O of n, since we are going over the array just once at max. And the space would also be, the space would be O of 1 because we're not using any additional space. So yeah, that's it.